Hello everyone, this is Samrat Pokhrel, Junior in Environmental Engineering in Texas Tech University. So please do like and subscribe to keep me motivating to post numerous important problems in environmental kinematics and thermodynamics throughout the semester. So this is a question from environmental kinematic and thermodynamics from a very first chapter, Introduction and Measurements. So we have given that concentration of O3 ozone in benzene at temperature 30 degrees Celsius and pressure 1 atomic pressure is 125 parts per billion, and we have to find what is the concentration in microgram per meter cube. So first thing first, what does parts per billion by volume means? So parts per billion by volume equals volume in O3, in this case ozone, by total volume of air times 10 to the power 9. So what does that implies in this question? Solution: 125 parts per billion by volume equals, we have 125 milliliter of ozone in 10 to the power 9 milliliter of air. Since it is parts per billion by volume, we have the units in volume and volume. If it was parts per billion by moles, then we have moles in moles. If it was parts per billion by mass, we have mass by mass. Here will be mass of O3 by total mass of air times 10 to the power 9. So equals to 125 milliliter of O3 in 10 to the power 3 liter of air. Convert this into liter, it will give you 10 to the power 3 liter of air equals, divided by 1000 of O3 in 1 meter cube of air. Why am I trying to do meter cube here? Because I want the concentration in meter cube, and also as we know 1 meter cube equals to 10 to the power 3 liter. Okay, then what we have to do is now use PV equals nRT, or how much is the pressure? 1 atm, that is given in the question. And also for the volume I have to do, so since I have the volume in milliliter, let's convert that in liter and put it on the equation. 0.125 milliliter by 10 to the power 3, that gives us unit in liter, equals to, and what I'm trying to do is find the mole of O3 present in 10 to the power 9 milliliter of air, and RT. So there are numerous values of R depending on the units. So here what we use is 0.0821, and that is in liter atm per mole Kelvin. We have given Kelvin, we have given atm here, we have given liter, and we need to find the value of n in mole, so we use this value. Okay, times how much is the temperature here? Temperature is, we have to put in Kelvin, so 30 plus 273. Then solve this, and equals, divided by 10 to the power 3 times 0.0821 times 3 What does that gives us? It gives us 5.024 times 10 to the power negative 6 moles. So this is the number of moles of ozone present in the air. Then what we try to do, we have to find mass. Since we have to find the concentration in microgram, let's find the mass of O3 present in the air. Then, as we know, molecular weight of O3 equals to 16 times 3, oxygen times 3 equals 48 gram per mole. Then, as we know, number of moles present equals given weight by molecular weight. Now mass of O3 is equal to this time this. How much mole we got? 5.024 times 10 to the power negative 6 times, what is the molecular weight? 48. That gives us 2.411 times 10 to the power negative 4 gram. Again, we have to find concentration in microgram per meter cube. So concentration of O3 equals to given gram by total volume. Why? Because we have to find concentration in gram by meter cube. So how much we find the mass of O3 to be? 2.41 times 10 to the power negative 4 gram by how much the volume? The volume is 1 meter cube of air, because we use this volume present in 1 meter cube of air to find the moles of O3. So the volume is 1 meter cube. So 2.411 times 10 to the power negative 4 grams times 1 meter cube. So how many micrograms are present in 1 gram? That is 10 to the power 6 microgram, or 1 gram equals to 10 to the power 6 microgram, equals to, the answer is 241.152 microgram per meter cube. The question was simple, and you got the answer to be 241.152 microgram per meter cube. Thank you.